Assalamu alaikum students. Today I am here with another H NMR problem. Till now I have discussed briefly some important topics in H NMR series which are required to solve simple H NMR problems. So we have discussed chemical equivalence, integral and integration, chemical environment and chemical shift value, and spin splitting, that is n+1 rule. These are the topics which are required to solve simple H NMR problems. If you haven't watched that lectures, then I recommend you to watch these lectures for better understanding to solve simple H NMR problem. I will attach link of this series in a discussion box. In the previous two videos of H NMR series lectures, I have discussed these two problems. If you want to learn how to solve these problems, then don't forget to watch the previous two videos as well, so you will understand how to solve these problems. Now come to today's problem. So it is a 17th problem, and the question is the compound that gives the following NMR spectrum has a formula C3H6Br2. Draw the structure. So how we have to solve it? And in previous video I have already discussed that the molecular formula, IHD, functional group, fragments, and then fragments account. So to solve the H NMR problem, we need molecular formula and we find IHD, and I have discussed IHD, how to find IHD in other series as well. So if you don't know how to find IHD, then go in the playlist and find it out. Then third thing, we need functional group, which could be find out by the IR. So but usually in the simple H NMR problem it is mentioned that which functional group is present in the molecule. Then we find out the fragments with the help of the spectrum. Then we combine these fragments so we can get the structure. Let's discuss okay, I am going to talk about this speed, right? So you can see here it is basically what it is: 1, 2, 3, 4 and 5. So it is 5 means that it is quintet. So okay, you can see here this is integration, basically 2.03, which means that there are two hydrogen which are splitting into quintet, right? Which means that the neighboring carbon contain 4 hydrogens, right? So there are two possibilities that how neighboring carbon can contain 4 hydrogens, right? So you can see here the first possibility is this, in which this is basically that CH2 which is splitting into quintet. So there is 1 hydrogen and there are 3 hydrogens. So due to the 4 hydrogens, it is splitting into quintet. But you can see here, if this is the case, then how many peaks should appear here? So if this is the case, then there must be 3 peaks, at least 3 peaks must be here. But in the spectrum you can see here there are 2 peaks. So the second option would be this one, and you can see here this is the CH2, right? These 2 hydrogen which are splitting into quintet due to the presence of this CH2 group, that is the 2 hydrogen at this carbon and the other 2 hydrogen at this carbon. So if you see this fragment, so you can see here that this is symmetrical. So due to this reason, there are 2 peaks in the spectrum, right? Okay, let's move to this peak. So you can see here the integral is 4.12, which means that there are 4 hydrogens, right, which are equal. chemically active, right? And it is giving what? It is giving triplet, right? 1, 2 and 3, so it's giving triplet. So what is mean by triplet? Triplet mean that the carbon which is attached to the hydrogen is connected to the carbon which have two hydrogens, right? So you can see here, this is CH2 and this is CH2, right? Two hydrogen and two hydrogen, so the total are 4. So these 4 hydrogens are splitting into triplet due to this CH2 group, right? And due to this CH2 group, it is splitting into triplets. Let's move. Okay, so this is the structure. Why I am saying that this is the structure? Because there are 2 bromines are also present. So you can see here the CH2 and CH2. So this carbon is attached to Br and this carbon is attached to Br. So the final structure is this. So you can see here there are 2 peaks in the spectrum, which means that there are 2 types of hydrogen present in the molecule, and you can see here the molecule is symmetrical, so the 2 types of hydrogens are present. So this is CH2, which is this one, and this CH2 is due to this one, right? So this is all about today's lecture.